Welcome, this is 7.6. This is the last section on the quadratics. How do we model a car's gasoline mileage using a quadratic? So they give us the data, and like you've seen in other data or sequences, this forms, well, you can really see the quadratic because there's the highest point and then it's coming back down. So we need to predict what the miles per gallon will be at 35 miles per hour. So they're giving us the speed on a data thing. That pin is toast. Okay. So they're giving us the speed and then the gas miles per gallon. Okay. Good variable might be S. So this would be F of S, because your miles per gallon is dependent on your speed. Remember, speed and time usually is always your independent variable. Does that make sense? Your speed's going to be independent. Your miles per gallon is dependent upon the speed. Okay? So first thing I would do is I would take this data and I would plot it in a scatter plot. You can do it on the calculator or by hand, preferably by hand, although you're all proficient now at the calculator. So I plugged in the points already. You can see that it's forming a parabola, and it's asking, is it a max or a min? Hopefully you can see it's going up like that. So we'd say a max. What is the maximum? The maximum from our graph appears to be 29.1 miles per gallon. Okay. At what speeds are the miles per gallon increasing? Well, increasing means it's going with a positive slope, so that would be clear up to 55. It's all of these going up to 55, so from 40 to 55. And you could probably, since it's real world, say from 0 to 55. Decreasing, it's from 55 up. Since we don't have an upper limit, we might say 70. Okay? Maybe put a plus there, meaning you could go beyond that. Okay? So our maximum amount is 29. Now we need to kind of come up with an equation here. So if we take our vertex 2955 and plug it in, then the other point that hit upon the scatter plot really well was 6028. So remember, this is your S, and this is your MS, or FS, however you're going to say it. And it is an upside down U, it's got the negative A. Let's just plug the numbers in and see how it comes out. So we have 28 equals A 60 minus 55 squared plus 29. Okay, so we subtract 29 from each side. We're just solving for A right now. Subtract 29 from each side, so we get a negative 1 equals A 5 squared. I need that negative in there. Okay, so 5 squared is 25. Actually, I wouldn't have to have the negative. If I have the negative, it's not going to solve as a negative. If I don't have it, okay, I'll just leave it as A, and then we'll get the negative when we solve it. We divide by 25, and that proves that we have a negative 1/25 out front there. So we can simply write it in there, negative 1/25, and we have our equation. Now we could plug in for the 35 miles per hour, because that's an S. So we plug in that value. Didn't really leave room, but let me see if I can squeeze it in here on the side. we have ms, miles per gallon, negative 1/25 times 35 minus 55 squared plus 29. 35 minus 55 would be a negative 20 squared plus 29. Negative 20 times negative 20 is 400 over 25. How many times does 25 go into 400? 25, 4 quarters in a dollar, or 16. So negative 16 plus 29 equals my miles per gallon. So negative 16 and a positive 29 would be positive 13. So we're getting 13 miles per gallon when we travel at 35 miles per hour. Okay? See you in class. Bring your questions.